For our warm-up today, the first question, analysis of variance is a statistical method of comparing the means, the answer here is C, of several populations. You want to run an ANOVA on 3 groups. Which of the following sets of hypotheses should you use for your test? Correct answer here is A. The null hypothesis is that all the means are equal. So you have mu of group 1 is equal to mu of group 2 is equal to mu of group 3. The alternative is that at least one has a different mean. At least one of the group means is going to be different. That doesn't mean that all 3 can't be different, but at least one is going to be different is your alternative. So today you guys are starting the Chapter 5 project. The first thing you're going to do is choose a partner to work with. Okay, we want you practicing 5.1 and 5.2 in RStudio. The reason we want you to practice with both the independent t-test and the ANOVA test is we aren't for sure which one is going to be on the lab exam. And our lab exam is coming up pretty quickly after Chapter 6. And so we want to start preparing for that. And we don't want you to have to do double the work. And to be honest, we don't want to grade twice as many projects. So we're going to partner you guys up and we're going to assign you to do 5.1 as a project and 5.2 as a project. But each partner, you're going to work together and 2 of you are going to complete those 2. Hopefully that makes sense, but you'll see what I mean. So you're going to choose a partner today. You're going to sign up for what your subsets are going to be, and then you're going to start working on your project. You will have a few days to work on this, but we want to make sure to get as much done today as possible because you know your time clicks away pretty fast. So the first thing you want to do is go over to Schoology and look in the Chapter 5 resource folder. And you want to click on the project sign up. We really had a lot of trouble on our Chapter 4 project with people going in and changing names and filling in names on files and variables that other students had already chosen, and it really did cause some problems. So sorry, not sorry, you're going to be assigned what file name you're going to use and what numeric variable you're going to use. After that, you get to pick how you're going to subset. So I'm making the example that me and Miss Green are going to be partners, okay? So between the 2 of us, one of us has to do 5.1 and the other one is going to do 5.2. But in reality, we're working on both of them together and we're submitting them together. So when you go back to Schoology and you actually click on your project, you're going to start it here, obviously, but I'm not going to do it that way. I've already got it open. It's going to be 18 slides instead of 9. So the first 9 slides are when the 2 of you are putting together your independent t-test. Okay, I tried to make it clear, I hope. I did the light orange for the 5.1 independent t-test slides. Then when you get to the really dark burnt orange, that's where you're going to start your 5.2 ANOVA part of your project. And so you have the same 9 slides as they relate to ANOVA now. Okay, on the title slide, we definitely want you to put both students' names. So I would put, probably put Miss Green first, just alphabetically. Her last name does come first. Okay, and so I would do that on both, and I would put our due date and our title name and all that good stuff. So do definitely make sure, do not change the slides around. Do not, as far as like the order of the slides, don't change those around. Don't create your own slides. Of course, you can change font colors and sizes and types and all that stuff, but don't move the slides around and don't change what's on the slides. So hopefully that makes sense why there's 18 slides instead of 9. When we get ready to print them at the very end, once it's collected, I don't want to forget to tell you this part, so I'm going to tell you real quick. You're going to go to File, you're going to go to Print. Remember, we're going to save it as a PDF, but for the pages per sheet, we want to do 9. And so that's going to give us just 2 pages that we're printing. And we are going to ask, and so right now I'm going to save it as that PDF. When we then go to print it later, we're going to print it front and back. So when I go find that and I actually open up that PDF, when I go to print it, I would want to do it front and back. So you're turning in a single piece of paper with your 5.1 independent t-test on the front and then your 5.2 ANOVA on the back. So single sheet of paper, I hope that makes sense. All right, moving on back to it. So you need to come to the sign-up sheet and you're going to decide what subsets you're going to use. So I am locked into, I have to use the example data and I have to use the numeric variable cholesterol, but I have to subset on something else. So let me go take a look at that data really quick. I'm going to import the example data. I'm going to call it example. And I need to subset something else besides cholesterol. Cholesterol is my numerical variable. That's what I'm doing the means of. That's what I'm doing the t-test on, all that. I'm going to go ahead and subset diabetic. Whether yes for diabetic is going to be one group and no is going to be the other group. Remember, for the t-test, you can only have two subsets or two groups that you're comparing. To do the 5.1 independent t-test, you do want to follow the 4.2 lab script. So I'm going to come down here to Files. You should be on Project and then On-Ramp Scripts. And I'm going to open up, I said 4.2, maybe it's 4.3. Sorry about that. So I'm saying the wrong ones completely. Scratch all that. We should be doing 5.1. So 5.1 is our independent t-test, and then 5.2 is our ANOVA. Sorry, guys. So 5.1 is the script we want to follow. I'm just going to come in here and right when I don't really care about seeing the first few observations. So right here where it starts subsetting, I'm just going to copy all this. You never want to code in your lab script because when you make those changes, it does in fact change it in your script, and you want your script to be original, what it started out being. So don't make any changes there. I really copied and pasted over everything I need, so I'm going to go ahead and exit out my script. You guys know I cannot stand all the in-between commentary, so I'm going to go ahead and quickly get rid of that. This is going to take me a minute, guys, but I think it's worth kind of walking through this with me. So I said I was going to subset whether or not you had diabetes. So create a subset of those. We'll go with diabetes and then we'll go without diabetes. Okay. So we're going to do, I'm going to call them DIA, just DIA for diabetes. This post was the file name that they were, or the file they were pulling from before. So where it says post, we're going to put example. Or I'm going to put example. My Greek is the variable they were subsetting. I said I was going to subset based on if you had diabetes or not, which is called diabetic. So we're going to do yes, that they are diabetic. Let me go check that. It does say that. Diabetic, yes, and it is lowercase. So that should be ready to run to get everybody who has diabetes in one file. So diabetic, and it just says yes, straight down it, all 18 people. So now we want to come back and do the same thing for people without diabetes. So this here they were doing the people that do not have, we're not in the Greek life, we're not in a sorority or a fraternity, but we're going to do the ones without diabetes. And so I'm going to call this not dia for not having diabetes. Example still good. Diabetic is still good, but this needs to say no instead. So I'm going to run that, and now I have 47 observations in not diabetes. We need to visualize the distribution of cholesterol is the numeric variable that I have to look at, and I don't have a choice on that. On the sign-up sheet, it does say I have to do cholesterol. Let me go back a second and say that my two subsets are diabetic, yes, and then diabetic, no. I don't need to put one here because my independent t-test is only going to have two groups. When I go over two groups, that's when I'm going to be doing the ANOVA. And I do need to go ahead and fill in that my partner is Carla Green and she'll have to fill in that her partner is Courtney Hall. So we should match up there and agree on that. You cannot work in groups of 3 or 4. It has to be partners. Okay, we want everybody to really spend some time doing 5.1 and 5.2, the independent t-test and ANOVA, as we get ready for exam 5, but then also getting ready for the lab exam that's coming up very quickly. Okay, so back at it, I've done my subsetting. I'm going to visualize. We know to visualize, we use HIST for histogram. Let's see, we don't want to do Greek, we want to do dia for diabetic. And then that numeric variable that we are trying to take a look at is their cholesterol level. I want to do the same thing again, except for not dia. So I'm going to copy that code in and put it down below, but put not in front of my dia. So I'm getting a histogram of both, but you know what, guys? I do ask on the slide, when you give me the histogram, when you're visualizing your data, to be sure and label the axes and include a title. So you are going to have to go in and get the main equals, what is it? Main. Okay, so we're going to title our histogram. And so I was kind of looking through, I paused the video, but I'm going to come back here and show you that in 5.1 script, there was nowhere where they showed us how to title or change the labels of our histogram. But I noticed in 5.2, there was a lot of information on the box plot labeling. So I can go steal that. So I'm going to go steal after I already have main equals. So I'm going to go steal all this. And that's really all I want from here. So I'm going to exit that back out. Again, I'm just trying to label my histogram. And when we're dealing with a histogram, we don't typically label the y-axis. That one just goes in as frequency. So I'm actually going to take the y label off. So I have my main is going to be, what were my groups? My groups were diabetic or not diabetic. So cholesterol, with, without diabetes. Didn't mean to make it so long, but, and then my X label would be cholesterol, because that is the numerical variable. And I want the exact same thing, but for my diabetes patients. I did copy in too much, but I'll just paste it in, and then I will make sure to close my parentheses because I didn't, but I'll go take the not off. So I should get a histogram for the diabetes, and then I should get a histogram for the people without diabetes. And I do want to go ahead and make sure I decipher which one is with and which one is without. So diabetes needs to be the with title, and then the not diabetes needs to be the without title. So I can fix that really quick. So I'm going to sweep my plots and rerun those so that the titles will be better. So this is the cholesterol levels of the people that do not have diabetes, and this is the cholesterol level of the people that do have diabetes. They are definitely not roughly normal in any way, shape, or form. So I would just explain in my write-up that my sample size of 18 and 47 are definitely 47 is large enough, and then I would say something about 18 being pretty close to being large enough. So I'm going to proceed with caution because I do have that one sample size that's a tiny bit too low. Okay, got to keep going here. So we're going to find the mean in the difference in the cholesterol levels. And so I'm going to do not diabetic, so not dia, and cholesterol. And then diabetic with cholesterol. Okay, so I'm going to take the not out. This is going to find the mean difference between my two groups. So that mean difference is negative 57. So is that truly significantly, a significant difference or not? So we're going to run a t-test on that. Let's see, we need not actually, if I copy this in, I think it should be what I need, because we need not $$ cholesterol. Let's see if that's what I had pasted before. Perfect. So I need that again so that I can just take the not off and run that. And it did our t-test for us. So we're going to look at our test statistic is negative 1.105. Our p-value is 0.28. Since our p-value is greater than 0.05, we're going to fail to reject the null hypothesis. So our null hypothesis is that the mean of people with diabetes would be equal to the mean of people without diabetes. So their mean cholesterol level would be the same whether you have diabetes or you don't have diabetes. And then the alternative hypothesis would be that they're not equal. So the mean with diabetes is not equal to the mean without diabetes. And since we're failing to reject, we do not have evidence that there's a significant difference. So having diabetes or not doesn't seem to affect your cholesterol level in a significant way. So you would have to go through and answer your first 9 slides with everything I just did. And don't forget that you do need to label what your T criticals are. And so my degree of freedom, so that I could look on the t-table to get my t-critical, would be 17, because we are going to take the smaller sample size and subtract 1, and then go look it up on the t-table to be able to label your t-criticals here. You can just put the p-value and the test statistic that you found in RStudio. So you are going to put the 0.2814, so you would type the 2814 here. You would type that negative 1.105 here, and you're going to drag it, and since we're failing to reject, it is going to be between the two critical values in that failed to reject region. So make sure you're putting all those values in, but that's why I have these where you can kind of put the values in and drag them around so that you can put them where they are supposed to go appropriately. Please don't add anything extra to this slide. I don't need it more detailed than this. Okay. Then under the conclusion, you're going to, reject and fail to reject, and do I have evidence and do I not have evidence and all that. But this is where we do want you to include the code. And all we're asking for is once all of this works, you're going to copy that in and you're going to paste it here in the speaker notes. And that is what you're going to just leave there, just in case we have to run anything to double check any of your calculations or any of that. I'm actually going to fix this slide also back to what it was originally. Okay, perfect. All right, moving on, we are going to talk, and so that walks you through the independent t-test. Sorry, you do need to do the limitations and the implications, but we did that in chapter 4, so I think you get the idea there. So this one starts our 5.2 ANOVA project. So we are going to start fresh here. And I am not going to do exactly the way she's actually not Sally Ragsdale did in the video. She did do cholesterol, and she did do the 3 different levels of exercising, whether it be never, sometimes, or often. What I'm not doing that Sally did in the video was subsetting out the people who had, over 100 for something, and then they also had to have diabetes. I think it was like they had over 100 for their heart rate or something. Was that what it was? When we did that in class last time. So I think, or was it their blood pressure? Maybe she did their blood pressure over 100. Nope, because that doesn't have anybody. I know she did diabetic, yes. Maybe she did their heart rate over 100, and these were the people she kept. So they were either yes for diabetes or over 100 for their heart rate or something like that. Or maybe they were less than 100. All that to say, I'm not doing that part this time. All I'm going to do is run this just like we ran the 5.2 script for your high school lab. I'm not going to copy the entire thing. I am going to do the subsetting in the beginning, and I'm only going to copy to where it says Tukey for the first time. So over here with my Tukey, copy all this, put that in a new script window, And now I'm pretty much done with the lab script, okay? So for 5.2, the ANOVA part of this, again, you're going to make sure to put both partners' names here. So this is essentially Miss Green would be doing this one. So she would say, my partner is Courtney Hall. So we're going to use hers to do the example data cholesterol. And these should not be filled in for you. Okay. I have chosen to do those as my subsets, or as mine and Miss Green subsets. So we're going to pick our subset to be exercise, and we're going to put them in 3 groups. Remember, to do ANOVA, you have to have 3 or more groups. So if you need to come in here and insert another column, you are welcome to do that. I just figured most students aren't going to want to work with more than 2 subsets. But if you're doing something like freshmen, sophomore, juniors, and seniors for Karloff, and you really want to look at all 4 of the different classifications, you can add in a column if you need to. I believe I have that set up where you can do that. If it's locked and you can't do that, and you want to put your 4th subset over here in column H, I'm okay with that as well. We'll figure that out. But I just figured most of you guys are going to want to stick to just 3. So again, one of your partnerships, you have to have only 2 subsets to do the independent t-test, and then the other person in the partnership is going to have the 3 to do ANOVA. And so we're going to go in and we are going to use what we have here. I don't think I'm going to walk you through every bit of this, guys, but I'm just going to talk you through what you would do. So you would subset. Okay, let me just do it. So we're going to subset by exercise. So I'm going to call it my exer. And so my file that I'm pulling from is example. And then it is exercise. And it is what? Never, I think, is the first one. And I'm going to double check that it is capital, exercise never, and then sometimes, and then often. So I'm going to grab example exercise never, and I'm going to paste it here. And I'll go change that word in a minute. I'm going to paste it at the end. Don't lose your comma. Don't want to lose your comma. So never, and then sometimes, and then often is the last one. It is going to be different than what we did earlier with Sally Ragsdale. So from Sally's, we went from 65 to 60 when we did our subsetting. But we subsetted out people that had, I think, lower than 100 heart rate, or they had diabetes. And so we did lose 5 people. With this one, everybody answered either never, sometimes, or often for exercising. And so it keeps everybody. And that's great. So we've got our my exercise created. Now we're going to find the mean and the standard deviation. So we're going to do it the way the script does it, not the way Sally's video does it. So instead of my films, it is going to be my exer for my exercise group. Instead of days, now it's going to be cholesterol. Everywhere it says days, we're studying their cholesterol levels. Okay, by list instead of studio. So the my films was the studio. And so instead of studio, it's going to be exercise. So maybe, I don't know, somewhere up top, remind yourself somehow that everywhere it's days, that actually equals the cholesterol level. So days was their numeric variable, and our numeric variable is cholesterol. And then everywhere it says studio, ours was exercise, and that was the thing that we subsetted on. So they subsetted the studios in the film data file, or whatever we worked with in the high school lab. They subsetted Sony, Warner Brothers, and Fox. We're subsetting exercise with never, sometimes, an example, and often, sorry. So that's just my kind of reminder that everywhere it says days, I need to change it to cholesterol. Everywhere it says studio, I need to change it to exercise. Everywhere it says my films, I changed that, and my films, I changed that to my exer for exercise. Okay, so those are my little hints up there up top to make sure I'm putting the right things in the right spot. So my exer, cholesterol, exercise. Let's see, my film should be my exer. Studio should be exercise. And we're going to run it and hope for the best. And I have all three. Yay! Never is 433.4, often is 276.5, sometimes is 326.3. These are their approximate cholesterol levels. Nothing's going to change in my next line of code, except instead of mean, we want SD. So I can go in and just copy paste and rerun it. And so now I have my standard deviations, which you will need to put in your slide that asks you to describe. Let's see. There's the visuals. We haven't done those yet. It's the descriptive statistics. You do need to give the center and the spread. So those are the numbers that you'll be adding to the slide 14. These numbers here. Moving on, we need the box plot, and the slide does require you to give the box plot. So box plot of my XR, but with cholesterol instead of days. Again, if you forget what goes where, look at our little cheat sheet we made at the top. So remember, days was cholesterol. So something like this might be really important for y'all to like write on a piece of scratch paper, so you make sure you're filling everything in the right spots. My films is my XR again. Studio, remember we replaced studio with exercise. And then we need to just give it a title. So cholesterol level is going to be my title. My Y label, instead of days, what was our days? Days is our cholesterol. And then what was our studio? Instead of studio, ours is how, like, the amount that they exercised. I'm just going to call it exercise. Let's run that, see what that looks like. So we do have some pretty good looking box plots here. We do not have a good variance for never. It's definitely much more spread out than often and sometimes. So that's something to address in the assumption slide, that no, the variances don't look approximately equal. So this is really a problem. This person, especially being the outlier here, we would want to talk about that. But I'm going to keep on going. So we're then going to we're going to create a model. So let's call it model, instead of days, what are we doing? We're doing cholesterol. So let's call it model COL for cholesterol. AOV, my films, is actually my XR. Days, what is days again, guys? Days is cholesterol. Cholesterol. And then instead of my films, we have my XR. And instead of studio, what is studio again? Studio is exercise. Okay, we're going to run all that, and then we're going to get a summary of our model cholesterol. So I can run it all together. So it created it. It did not like the way I did that because I put an S somewhere. Instead of my XR, I did XRs. Okay, let me create it. Now it created it. Let's make sure over here that it did. In fact, it created model cholesterol list of 13. Now let's look at the summary of it. So this is our ANOVA test, you guys. This is our F statistic of 7.417. So on my slide, I would go in and I would put my F statistic here, 7.417. Based on this p-value of 0.00129, I would be rejecting the null hypothesis. Remember that your null is that all your means are equal, and then your alternative is that at least one is different. I don't know which one, but at least one is different. We have evidence, since we're rejecting, that at least one of the groups is different. And so since I know I'm rejecting, this F statistic should definitely be to the right of the F critical. If your p-value happens to be bigger than 0.05, then I am going to ask that you drag this to the fail to reject side. But ours is, in fact, rejecting, so we would want to say down here on the reject side. So you would put your F statistic here, you would put your p-value here, and then you would move on to write your conclusion. Within your conclusion, be sure to give the results of the post hoc analysis, or if you failed to reject, then explain why it was unnecessary. So if you don't have the results of the Tukey test because you didn't have to run it, then instead of giving those results, then you want to make sure to talk about why you did not need to run a post hoc analysis. If you're failing to reject, then you do not have evidence that any of them are different, any of the means are different, so you don't need to do the follow-up analysis. But we need to do it, and we're going to do it on model CHOL for the model cholesterol. And when we run that, you're looking at this p-adjusted to see which of these is less than 0.05. So the first two are less than 0.05. So often with never was significantly different, and sometimes with never was significantly different. And so on this conclusion slide, you would talk about that those two combinations, those two comparison groups, were definitely significantly different. Those cholesterol averages were very different from each other, but the sometimes and often didn't really have a significant difference, even though you can look at the averages back up here and see that sometimes had a higher cholesterol average than often. According to this data, it wasn't a significant difference. Only often with never, and then sometimes with never. So you're going to fill out all your limitations and implications that go along with collecting your data and analyzing it and parts of your study. And I hope that gives you a good idea of how you're going to complete this project. I do sincerely hope that helps. I just stress that, you guys are making sure to follow the directions on each slide, and definitely change this gray to what you need to type in. You don't need to come and type below it. Like, don't start typing your conclusion down here. Replace what I have on the slide as your instructions. But for each slide, you guys should be reading these and doing what it asks. And don't forget that on slide 16, you need to put your code in. So you do need to come and grab. I don't need the console, guys. I just need your correct code that you used to complete the project. So I hope I covered it all. So you put it down here in the speaker notes. So again, make sure you subset. Do not subset on the same thing as your numeric variable. Leave your numeric variable alone until you're testing it. So subset on a different variable. What you're subsetting on can be categorical or it could be numerical. Either one is fine. Make sure you give us your partner name. Make sure you're on the correct tab at the bottom depending on what period you're in. So I lost connection, but I'm going to just keep talking a second. So just make sure you do fill this out. Do not, if for some reason I don't have this spreadsheet locked down when you look at it, make sure you leave everybody's names and file names and all that alone. It should be locked where we can't edit and make any changes, but leave them alone if you can. All you're supposed to be filling in is the subset columns and your partner name. And so that should get you guys going on your project. Good luck. We want some great projects and some great review getting ready for exam 5 and getting ready for that lab exam.